I like how you're skipping the expression part. You know, convenient, right? So we know it is increasing. That means our m prime is always what? Positive. Very good. Okay, and then I want to also kind of emphasize t is in place of x, m of t is in place of y. So as I solve for them, especially for the tangent line, I'm going to use x and y and then kind of convert it to t and m. And then it says at t equals 0, they give us a point. At 0, our m is 5. And that's going to be really helpful for us to find the c value. So just by looking at this, would you agree this point right here is 40? Yeah? And not only that, they kind of mention it, m of t less than 40. If I were to kind of go along the slope field, and they said to start at 5, and just kind of go along and see where it's going to end up, somewhere over here. If you're off a little bit by a millimeter or two, that's fine. Let's actually sketch this and see what the AP test wants. So when I sketch this, part A. Part A is basically, here's our vertical and horizontal, and you want to always label them. Here's my t, here's my m of t. And then I have my horizontal asymptote at 40. I think I'm gonna write like a dotted line over here to show that I'm not gonna touch it, but almost close to, starting at 5. And the graph looks something like this. And that is gonna give you 1 point. And it should be easy 1 point. So if you're like, hey, I can do this on my own, put a check next to the 1 point. Should we all be able to do this? We're just going along the slope field. Okay, part B. Karis, let's read.
Use the line tangent to the graph of m at t equals 0 to obtain m of 2, the temperature of milk at time t equals 2.
So I need a tangent line through t equals 0. Now at t equals 0, do I already know the y value? Yeah, they gave us 0, 5. So let's actually solve for it. And let's write out the equation somewhere up here. Maybe it'll be helpful. We have dm over dt is equal to 1 over 4 times 40 minus m. Okay, for tangent line, we need a point and a slope. So let's write, we have a point, 0, 5. We need our slope, and slope is dm over dt. Don't we already know dm over dt by the given? Yeah? So if I plug it in, I get 1 over 4 is not equal to, times 40 minus 5. And again, this is non-calc. So what is 40 minus 5? 35 over 4. Getting to that slope alone is 1 point. So can you plug in the given x and y? If the answer is yes, put a check mark next to that one. So as we go over this, this should be easier and easier by the day. So let's write our tangent line then. Our tangent line was y minus y1, which is 5, is equal to my slope, 35 over 4, x minus x1, which is our 0, which is really not needed, right? So let's write this in terms of m and t, because they didn't give us x and y. So I'm going to write out m is equal to 35 over 4t, and I'm going to move the 5 over by saying plus 5. What number did they ask us to plug in? 2. So let's put in m of 2. It's going to give me 35 over 4 times 2 plus 5. Now, because it's a FRQ, as long as you plug in the actual number, can I leave it like this? Yeah, for sure. Leave it just like that. And we always need the degree Celsius. And let's see what they asked us to do. It says, use a line tangent, and we did all that. Okay, so this right here is going to give you 1 point. If you want to be elaborate and write approximate of m of 2 is equal to this, that's up to you, okay? But we have answered every part of it. So if you can get to that, put a check next to it. Let's go to C. Jacqueline, let's read C, please.
Whether the approximation from part B is understatement or an overstatement for the actual value of m
When they ever talk about underestimate or overestimate, it has to do with concave up or concave down, okay? So if it's concavity, we're looking for where second derivative is either positive or negative. So let's actually solve for it. And again, if it helps for you to write out the equation on top, go for it. I think I'm gonna simplify it. So let's do dm over dt is equal to, I am going to distribute the 1/4, 10 minus 1/4 m, because deriving that is so much easier. We're simply deriving the second portion. So let's all write out d squared m over dt squared. What is the derivative of this guy over here? Negative 1/4, and we are deriving implicitly, so we need to add dm over dt. That's multiplied. And then our question is, what about this right here? Wasn't that already in our original equation given to us? Well, so let's plug it in. That is negative 1/4 from the original. Let me put this down. It gave us, I'm gonna start with the bracket because I'm thinking ahead, 1/4 times 40 minus m. And then I want to further simplify one more step. We have negative 1 over 16, 40 minus m. So what is my m at t equals 0? 5. So if I plug in the m right here, that's going to give me 35 inside the parentheses, correct? And then if I multiply by a negative, what do I get? It is a negative number. All I care about is it a positive or a negative number? That gives me concavity. So let's write on here. So this means it's concave up or down. So concave down. And I like a visual. If you can visualize it in your head, cool. So concave down. And my tangent line was right here. So if that is the case, and I make a vertical line anywhere, here's my tangent approximation. Here's my actual. So if I use my tangent line to find it, was it over or underestimate? Over. So I'm going to write on here the approximate from part B. You could say part B because they said part B as well. Is overestimate. And we always need the reasoning because, should I say because it is concave down? We do not want to use the word it. The graph is. Graph, I should say of M is concave down. So make sure you're not using it, they, and so on. Be very specific. So our points from this one, let's see. All the way up to, where was it? All this right here is 1 point. And then our final with the justification, 1 point. That means 4 points are gonna go to part D, meaning it's gonna take a little more effort, okay? But it looks like part A already saved us a lot of time anyways. So we can pour our soul into part D. So again, grade yourself. Is it potential? Check, and so on. Because I'm gonna send out a Schoology thing for grading the 2023 portion. Okay, Marissa, let's read part D.
Use separation of variables to find an expression for M of t, the particular solution to the differential equation 1/4 with initial condition M of 0 equals 5.
Okay, so let's go ahead and do this. The first thing we're gonna do is we wanna put the m's together and then the t's together. So I'm gonna move this guy over here by dividing and move dt by multiplying. That's applying algebra 1. So let's do that. So we have 1 over 40 minus m dm is equal to 1/4 dt. The right side is pretty easy. I want to worry about the left side. On my left side, we're going to let u equal what? 40 minus m. Let's do that on the side. So we have u is equal to 40 minus m. So du is equal to what kind of dm? Negative dm. And we do not see negative dm, so I need to kick off the negative to the du. So let's do our direct substitution. We have 1 over u. And then we have du. We are going to integrate it. I forgot to put the integral. So we have negative kicked out. So we should be very comfortable with integral of 1 over u. It was what? Thank you. Natural log of what kind? Absolute value. Once I eliminate the natural log, I'm going to naturally take out the absolute value. For now, let's carry it along. And then let's go to the other side. We have 1/4 integral is 1 over 4t plus c. So now I want to get rid of my negative. So if I want to get rid of my negative, I'm going to multiply by negative on the other side. We have natural log of the absolute value of 40 minus m. Negative 1/4 t. But constant, your c could be negative or positive in itself. So we're going to leave that as plus c. So now let's do our drop and cross. What is my understood base of natural log? E. So when I drop and cross, natural log goes away. So that means my absolute value goes away. So we have e to the power of negative 1/4 t plus c is equal to 40 minus m. And then I'm going to further elaborate. E is a number, c is a number. So technically, if I were to simplify this, it is c times e to the power of negative 1/4 t is equal to 40 minus m. What is my m given? 5. So let's plug in the 5 and the 0. So we have c e to the power of, I know that all that is going to be 0, is equal to 40 minus 5.
Wait, why does the c get to come down?
Where's that?
Why does the c get to come out of the exponent?
Okay, let's do a quick review. When back in the day you had x to the power of 1 plus 2, that was technically x to the power of 1 times x to the power of 2. So the c is a power of the e. E is a number. C is also a constant, some random number. Okay? All right. So when I plug this in, what is my c value? 35. So then let's carry that over. Which one do I want? This one? So we have 35 e to the power of negative 1/4 t is equal to 40 minus m. And I want to solve for m. So two things I'm going to move. I'm going to move the negative m by adding. I'm also going to move this whole chunk by subtracting. So we have m is equal to 40 minus 35 e to the power of 1/4 t. And they said to solve for m, and we did. So let's see. Let's see if they asked us to explain it. Where's my thing? Yep. So our point system. All this is 1 point. So can you separate the variables? Put the m's together, put the t's together. Hopefully everyone's going to say yes. And then having this value over here is another point. Our final answer, of course, is 1 point. Y'all wait. And then the whole chunk to find the c value is another point.